that have already fallen from trees. A shower of cool water completes the washing process. The apples are then cut into little pieces in this grinder and produce gratings. Enzymes are added which break down the cellular structure of the fruit, allowing for maximum juice extraction. Next, the gratings are transferred into maceration reservoirs where they'll stay for 60 to 90 minutes. Then they extract the juice. The gratings are pumped into a powerful hydraulic press. Inside the press, filter sleeves hold back the skins, seeds, and stems of the apples. Quality control is strict. At each stage of the process, they draw off samples of juice to evaluate its quality and to make sure that fabrication parameters are well adhered to. The juice is filtered a first time. The very smallest undesirable particles are held back by this sieve. The fabrication process continues. Juice flows from one stage to another via these immense reservoirs. The next step will be pasteurization. Juice enters this exchanger at 22 degrees and is heated up to 88 degrees centigrade, then cooled back down to 50 degrees. Enzymes are then added to hydrate the pectin and facilitate the second filtration. This is the ultrafiltration process, where filter membranes with microscopic pores retain the smallest of particles. The apple juice is now perfectly filtered. Its clarity is verified, as well as its flavor, color, and natural fruit sugar content. Since juice is produced in October, it has to be conserved throughout the year. A portion of the production is stored in this sterile warehouse area to await being bottled during the year. Each reservoir can hold 110,000 liters of filtered juice. No preserving agent is added. Now we move to the next stage, which is the filling of the containers. These little drinking containers are filled at the rate of 100 a minute. The containers are then hermetically sealed. Two little sprays of hot glue are applied to the containers. This secures the straws attached onto their sides. Another automated production line fills bottles with juice. They circulate in a row on this conveyor. Bottles are washed and disinfected with hydrogen peroxide in this white sterile room. Then they're rinsed with sterile water before being carried to the filling location. Each minute, 120 bottles are filled with pasteurized apple juice and sealed with a cap in a sterile environment. Bottles are then labeled and sent to shipping. Between 20 and 40,000 tons of apples are transformed into juice yearly. Thanks to its perfect preservation, consumers can enjoy this juice at any time of the year. Flying is great, but easing hundreds of tons of aircraft onto a runway safely requires some pretty sophisticated landing gear. Let's see how it's made. This heavy piece of steel is the undercarriage of a KC-135R airplane. A landing gear comprises a central shaft to which an axle and wheels are attached. They begin machining the shaft. This digital lathe machines the exterior surface of the part. Sprays of water and oil cool the part, which heats up due to friction. They're now going to pierce the shaft. This drill head will remount the inside of the shaft. Alignment of the head must be perfect, so they're cautious with their work. The perforating gets underway. Turnings from the cutting are saved, and these will be sold to foundries where they'll be recycled. We see here the cutting tool used to pierce the holes in the landing gear. To perforate the part, very sharp cutting tools are used. Here, they complete an attachment hole. The hole is enlarged on its sides as required by this machine tool. The part is cooled with a mix of water and oil. Cutting is completed and the hole is now cleaned out with compressed air so that they can proceed with a visual inspection. Here, 3 pieces are rough cut at the same time by this machine. Because they'll be used in aviation, these pieces have to be machined to perfection. The machining of the shaft is now almost completed. This deburring unit polishes the machined surfaces with a compressed air tool and sandpaper discs. And now they have to verify the dimensions of the parts. This digitally controlled machine has 3 axes and does the verification with extreme precision. Here, another unit allows for the machining of parts with greater dimensions. This facility also reconditions used landing gears such as this one from a Boeing 707. They strip off the paint with a sandblaster to verify the condition of the parts with great precision. And here are those parts stripped clean. But a visual inspection is not enough. They can detect cracks by magnetic particle concentration. They magnetize the part and any cracks will become visible under ultraviolet light. Now it's time for the shot metal procedure, where they spray steel balls onto the metal surface to increase its resistance to fatigue. Before repainting the part, they first plate it. The part is immersed for 10 minutes in cadmium, which forms a protective coating on it that will resist corrosion. Then the part is quickly soaked in a weak concentration of chromic acid. Water, agitated by air jets, cleans away the chromic acid, and the part is rinsed with water another time. The part is now baked at 190 degrees over 23 hours to remove hydrogen induced during the plating process.